Hi everybody, Eric here. Welcome back to Reading the F and Docs, where we learn Solidity together. And today, we're still in the basic section here, but we're almost out. We're running a few example Solidity contracts and then a few more videos, and we'll get into the actual language description. Today, we're talking about the blind auction example. This is actually a two-parter. I'm gonna do the second part in a different video. Today, we're going over our basic simple open auction. And I already went ahead and opened this up in Remix. So here's a contract itself. Oh, let's compile it. I did not interact with it yet. Okay. So in other videos, I talked about the concept of a smart contract, to think about it as state and some ways to interact with and manipulate that state. I'm going to expand on that a little bit. So what's our state here? We have 1, 2, 3, 4, 5, 6 different state variables, each of different data types. I want to introduce you to the concept of a state machine, which you may have heard of. If you haven't, you're probably going to hear this multiple, again and again throughout your journey as a blockchain developer. And this comes from mathematics. So basically, what it is, a state machine is the Ethereum blockchain is a state machine. And any smart contract is also a state machine. So in our case, we're going to have an auction. So we're going to have a high bidder and a high bid, some other things, but for some simplicity reasons, I'm putting those two items here in our state machine. So state number 1 is going to be initialized. The highest bidder is going to be the 0 address. The highest bid is going to be 0. And so this is state 1. Now in the state machine, there's also rules, and that's what the rest of our smart contract will define. And as if you interact with that state, according to certain rules, what you will get is another state. So in our case, if somebody places a bid and that transaction succeeds, now we're going to have a second state, which is the highest bidder will have an address that is not the 0 address, and it's going to have a bid. So in our case, we put a random address in, and maybe they bid 5 ETH or something. And that's our state 2. So this is a very simplified example of the concept of a state machine. I encourage you to study more about it. It actually comes from math. And there's a time and a place for theory, as engineers, period, especially smart contract engineers or blockchain engineers. But ultimately, we are engineers, so there's also a time to put down the textbooks and just get back into writing code. So let's do that now. What are the other states that we have? So we have a beneficiary. So this is an auction. So a beneficiary is a person who receives the money at the end of the auction. So if you think about an auction like they have on TV, there's usually a piece of artwork. The beneficiary could be the artist, or it could be the auction house, or it could be some charity, or a combination thereof. Maybe the money gets split, so forth. But that's what that is. We have an auction end time. So can't last forever. So this auction, is going to end at a certain time. And then after that, you can no longer place bids, and then we can calculate the winner and give them their money. Now, we already spoke about the highest bidder and the highest bid. The highest bidder is an address. This could be a smart contract. It could be a wallet. Our highest bid, that's just going to be the value of the highest bid. And whoever placed the highest bid wins the auction, wins the item, and that's whatever they place is the amount of money that the beneficiary will receive. Now, this mapping here, it's a mapping of pending returns, address to uint. So this is essentially everybody who bid will get placed in this pending returns if they don't win the auction. So for, I guess you can say, the loser. So every loser, there's going to be a structure called pending returns. You input their address and it will return a uint. Essentially means how much they've already bid, and this is how much money that they can get back. Boolean flag called ended, meaning has the auction ended or not. And this, this is a function of our auction end time. Okay, now we have some events and errors. Now these do not manipulate the state directly, but they're a reflection of the state. So we don't necessarily need these for our smart contract to behave appropriately. However, it is a best practice, and recommended. Now we're going to have some here for demonstration purposes, but for more complicated smart contracts, like say a DeFi protocol, you're going to want these. So events, basically, for any kind of operation, you want an event fire. So in our case, we have events for anytime the high bid increases, it'll fire an event. When the auction ends, it will fire an event. And what what a third party might be able to do is write a program that monitors this smart contract, listens for anytime an event increases, and maybe then they can automatically place their own bid. Or, if the auction ended, they can decide, okay, well, since the auction ended, I'm not going to place a bid. So those are some, reasons why you want your events. Now, errors, if the smart contract is written properly, the transactions will fail in the appropriate places. But if you have these custom errors, it'll give you a little more insight as to maybe why a transaction failed, if you want to maybe debug it, or try again, but do something a little differently next time. Maybe you didn't put a parameter set to the proper function and so forth. So these help you, just readability as you listen for and read the the logs of any transaction. So let's get started into the actual code. So now we have our constructor. So all this does is when this smart contract is deployed, it takes in two parameters: a bidding time and a beneficiary address. So the beneficiary address, again, this is the beneficiary. All this does is initialize our beneficiary variable up here. We can think of it, I guess we can think of it as more of a constant because this won't change in our case. And then we have a bidding time. So we can say, hey, we want this to be only last 1 week or 1 day or 1 year, who knows? And then that gets added to the current time. We're going to use block.timestamp, and that's going to give us the auction end time. We can go more into, there's more nuances to anything time related when it comes to the blockchain, and we can go over it in future videos. But that's basically what this is. It sets the length of the auction and gives us a definitive time that it ends. So that's it. Those get initialized in the constructor. Those won't change throughout the course of this smart contract's life. Well, I guess the life is forever, but functionality wise, it will end. Okay, so now we have 3 actual functions to interact with our contract. We can bid, we can withdraw, and we can end the auction. So let's start with bid. And by the way, my descriptions of these smart contracts may not be verbatim, or they're definitely not verbatim for the comments that the authors have put in. So I definitely recommend that you go through this on your own as well, and you'll probably catch other nuggets and other bits of wisdom and nuances and so forth as you go through their comments. This is just one more perspective. So let's go over our bid. So this is an external function. That means you can only call this from outside the contract. You can't call this from within the contract. Well, I take that back, but there's nuances here. Let's see. This is payable. So that means we are allowed to send money to the contract. So now we have a check here. Our contract might revert. So if block.timestamp, and we can just consider that to be the current time, if it's greater than the auction end time, well, that's going to mean that this auction is over and we're going to revert. And we're going to use our custom error, auction already ended. We have another check here. If message.value, meaning the size of the bid, message.value is the value of how much money the person wants to send along with this transaction. Now, if that is less than or equal to the highest bid, that means they are not the highest bidder, and there's no point of doing anything. Again, we will revert the transaction, and we're going to have our custom error, bid not high enough, and this one will actually take in a parameter of our highest bid. So that means somebody listening for listening to the logs of this contract, they're going to say, okay, this bid not high enough is the reason why this transaction reverted, and this is the amount of the bid that was too low. And we have another check here. If highest bid is not equal to 0, meaning, if we have a high bid of 0, wait, if high bid is not equal to 0. Okay, so if there's an existing highest bid, initially the high bid will be set to 0 by default, but if somebody already bid, the highest bid will not be equal to 0. Then pending returns, we get the pending returns object or mapping and the value of that previous highest bidder and add their highest bid to it. Meaning, so this person is no longer the high bidder. So we're going to give them the right to get back the money that they've since bid, that they previously bid. And that's what this is. We're storing that in our pending returns mapping. So now that we got that out of the way, we can now, if we are the caller of this function, we will set ourselves message.sender to the highest bidder, and we will set the amount that we sent in to the highest bid. And then we'll emit our event. So anyone listening to the blockchain can now know that the highest bid increased. And this is the person who placed that highest bid, and this is the value that they put in. Now we have our withdraw function. So once the contract is over, or I guess even before then, if you were no longer the highest bidder, you were at one point, somebody else came with a higher bid, you were no longer the highest bidder, well, you should get your money back. So here's where we're doing this. So this is the function to do that. So what are we doing here? You went amount, pending returns. So we grab our money we've sent in. We check the pending returns mapping, enter in our address. As you know, pending returns takes in an address and it will give us back a uint, which is the amount of money we've already placed into the contract. And we're just going to set that to a variable named amount. Now, if this amount, if the amount is 0, there's nothing to do. We just return true. If we have an actual amount there, then we set our pending return amount to 0. And then now we go ahead and send ourselves that amount. So we cast our address to payable to allow the contract to send us the money. And then we pass in the amount. Now this little exclamation point is the not logical not operator, meaning, so here's a transaction itself. If this transaction fails, that will trigger this not operator. That means this whole thing inside these two brackets or two parentheses rolls off to true, and then it triggers, the inside of this if statement. So we reset our pending returns value to this amount, and then this whole withdrawal function returns false. That means the transaction failed. That's a pretty interesting line right here. So there's a few things happening. By default, we can't just call send on our address here because this address is not told Solidity that it's a payable address, meaning that can receive either. So we do that by casting it with this payable keyword. Then we send the amount. And then if that fails, we go into this if statement. So I think that's a pretty unique little bit of code there. So that's how that works. And by the way, this withdraw function, so this is a best practice. So we could theoretically at the end of the auction, we loop through all of the these pending returns and just send everybody their money back. But for various reasons, which we can get into later, that's it can get complicated. It can get, there can be security vulnerabilities. So it is a best practice to do what's called a pool-based withdrawing mechanism, which is what we're doing here. So basically the money will sit there and it's up to each individual bidder to withdraw their money. if they're not, if they, if they get outbid. So it is an extra step for the bidder, but in terms of the smart contract itself, this is the preferred method. So now we have our auction end function, which actually doesn't use this method, but again, this is all here for illustration purposes. So when the auction ends, somebody and anybody, there's no access controls here. Anybody can call this function, and then it'll effectively end the auction. So what we'll do here, if the current time is less than the auction end time, meaning the auction isn't over, then we can't call this function, and it will revert, and we'll have our custom error here. Now, if the auction has in fact ended, and this was already called, we'll revert again. Auction end already called. Now, because this ended flag hasn't been set to true yet, this is still set to false. So we're about to set that now. So now if both those checks pass, we set ended to true, we emit our event that says the auction ended. And this one takes in two parameters: highest bidder, highest bid. So this is the win, the auction ended, and here's the person who won, and here's the amount. And then we send the highest bid amount to the beneficiary. And that's it. That's how the smart contract works. So that is it. That is our simple auction contract. And I hope this was helpful. My name is Eric. I work for CryptoPunks. Take care.